Hello, everyone, and welcome to today's webinar. We are just going to wait a few minutes just to ensure that all attendees are present, and then we will begin the webinar. Thank you. All right, so we will go ahead and get started. So hello and welcome to the Fall 2021 Roadway Watercourse Crossing webinar series, presented by the Alberta Watercourse Crossing Collaborative. My name is Matthew Huberto, and I'll be your host throughout this series. The Alberta Watercourse Crossing Collaborative is a non-for-profit organization whose primary objective is to restore lost and damaged fish habitat from poorly installed and maintained watercourse crossings. We achieve this objective through education and information transfer from subject matter experts to practitioners. This webinar was created to help achieve those objectives by discussing important topics in an easily accessible format. All these webinars are recorded and will be available on AWC3's website. Just a housekeeping note. The red box with the white arrow in the top right corner of your screen opens your webinar menu and allows you to type in questions. Questions will be answered at the end of the presentation. Today's webinar is on the Canadian Aquatic Barriers database and will be presented by Nick Mazany-Wright. Nick works at the Canadian Wildlife Federation as a spatial ecologist. Nick has a background in geospatial analysis and the restoration of freshwater and wetland ecosystems. His work includes using geospatial models and conservation planning tools to assess, prioritize, and restore freshwater connectivity and aquatic ecosystems. Without further ado, here's Nick.
Afternoon, everyone. Thanks for the kind introduction, Matthew. I will share my screen now once I have the ability to do so. There we go. Okay. Hopefully everyone can see my screen. Thanks everyone for joining today. As Matthew mentioned, I'm Nick Mazany-Wright from the Canadian Wildlife Federation. I know the agenda said that I'd be presenting on the Canadian Aquatic Barriers database, but you're getting two projects for the price of one today, because I'm also going to share some work that we've been doing recently around developing watershed connectivity remediation plans in BC that we're hoping to expand and apply in other parts of the country, including Alberta. Just a little bit more information about who we are at the Canadian Wildlife Federation. Sometimes we get confused with the Canadian Wildlife Service. We are not part of the federal government, but we are one of Canada's largest environmental NGOs. And our mission is to conserve and inspire the conservation of Canada's wildlife and habitats for the use and enjoyment of all. We do so through 3 conservation science programs focused on freshwater, marine, and terrestrial environments. And the pillars of our work are focused on science, education, and advocacy. The most relevant work to this webinar today that we've been doing is the development of a national fish passage program. Much of our freshwater program is now focused on connectivity and fish passage. And that includes Chinook salmon research in the Yukon River, including effectiveness monitoring of a fish ladder up there, as well as tracking returning salmon to figure out where they're actually going to spawn when they come back, and how many are making it back. We also do American eel research and advocacy around hydro facilities and turbine mortality. And we're also developing a fish passage advocacy program, including leading barrier remediation campaigns. But the 2 most relevant projects, and the ones that I'll be talking about today, are the Canadian Aquatic Barriers Database and the development of a watershed connectivity remediation planning framework that's customizable and flexible and can be applied in any watershed across Canada. So let's start with the Canadian Aquatic Barriers Database, or the CABD. So really our vision for the CABD is to have all of Canada's barrier and connectivity information in one place, without the need for extra software or technical expertise to access it. So as I mentioned, because we were developing this National Fish Passage program, we knew that we needed a standardized repository of a comprehensive repository of barriers that will allow us to strategically prioritize and select projects to move forward with. And we were inspired by a lot of great work that's gone on across North America, including by the Nature Conservancy in the northeastern US, the North Atlantic Aquatic Connectivity Collaborative, and the Nature Conservancy of Canada in the Atlantic region of Canada, who developed an aquatic connectivity tool. And so we viewed the CABD as a central pillar of tools to support our fish passage program. But as we began conceptualizing, what this database could look like, we realized if we're going to spend the resources and put in the time and effort to develop this database, there's going to be a lot more uses and requirements that expand just beyond our internal needs. And this applies across many sectors and fields of work. For example, connectivity research, hydrological modeling, infrastructure inventories. And so we kind of took a step back and decided to undertake some stakeholder engagement to make sure that we're creating a product that, while not being everything for everyone, is useful to the widest audiences as possible. And so we started with some user requirements interviews with different stakeholder types across the country, all levels of government, industry, NGOs, local conservation groups. And we asked them some key questions. What type of work could the CABD support? What are the key barrier types that you would like to see included? What information or attributes do you want to know about each of the barriers in the database? And what would be the best way for you to access that data? And so coming out of that stakeholder engagement, we're able to put together a working group and a technical advisory committee that continue to provide advice and feedback and guidance for us through the development of this project. And we've also worked and will continue to work to establish reciprocal data sharing relationships. The goal of the CABD is not to replace existing barrier repositories or data sets, so we're happy to take on that data management burden if it's useful for additional organizations. But we want to make sure that if organizations or groups are sharing data with us where we're able to fill data gaps, we want to provide that data back to them. So we view all of this as a reciprocal two-way street. So coming out of that stakeholder engagement, we were really able to identify 5 broad use types for the database. The first being regulation, policy, and reporting. And everything from Fisheries and Oceans Canada's State of Fish and Fish Habitat reporting to watershed scale reporting, to providing information to support regulatory decisions. That was a key use type that came out. The one that we started with is the second, which is restoration planning and prioritization. So comprehensive data sets allow us to strategically plan for barrier remediation. The third one was a bit of surprise for me personally, but we learned that there really isn't a whole lot of comprehensive inventories out there, and so there's interest from groups like transportation and infrastructure ministries and others around actually having this as an infrastructure asset management tool. The data can also support research and monitoring, and a key one for us, and I think more generally as well, is the ability to educate and support public outreach through the sharing of resources, best practices, success stories, things like that. So we were able to synthesize that down, and really what we came up with was that the CBD is going to need to be comprised of three components. We need an analysis-ready hydrographic network. For us at the national scale, this is based on the National Hydrographic Network, which is maintained by NHN. There are data error issues in the NHN, and so the ability to have a network analysis-ready set of stream and river networks was really important for users. So we've been developing some tools to support that. We need the barrier data itself with standardized attributes to facilitate ongoing data maintenance and management. And what another key outcome was that this data should be made available with analytical tools in the future through a web mapping interface. Some of the tools that have been developed previously on a more regional or local scale have been released as ArcGIS toolboxes or things that require sophisticated knowledge of and potentially expensive software. And so the ability to access everything through the web mapping interface was a need for a lot of our users. So what is the CBD and what will the CBD be? Well, it is an open source, standardized central repository for small and large barriers. So we want to run the gamut from large hydro dams all the way to the small barriers like stream crossings that dot the landscape and exert pretty significant cumulative effects on connectivity in watersheds. And so we hope that this CBD will meet the growing data needs for users. And we also want it to be sort of a centralizing network that allows and supports Canada-wide collaboration and the sharing of resources and information. So where are we at right now? So we're developing the CBD version 1, and it's a more limited than the long-term, a more limited version than the long-term view, simply because we wanted to manage data volume during the development and testing of the tools. So this initial release will include dams of all sizes, waterfalls, fishways, and the hydrographic networks. And in future years, we'll work to add additional barrier types, for example, stream crossings. So we were able to develop hydro data processing tools that spit out network analysis ready data formats. So anyone is able to take the networks that we've processed, and they will be able to perform network analysis without performing any kind of edits to flow directions or anything like that on their own. So it is analysis ready. And then for the barrier data itself, there's kind of two phases, and currently we're in phase 1. Phase 1 is to compile and standardize what's out there. So there's disparate data sources. I think for dams alone, we've compiled over 30 data sets from across the country. So we're in the process of compiling and standardizing those. And then in future years, we want to move into phase 2 to identify and develop mechanisms to fill those data gaps. Attribute sets are not complete. We're missing barrier types, and there are parts of the country that just don't have as don't have great coverage in terms of existing data sets. And so in the future, we also want to develop other tools, work with stakeholders across the country to evaluate the feasibility of standardized barrier assessment protocols. We want to work to develop a citizen science app for barrier identification and assessment, not necessarily developed from scratch, but potentially adopt or adapt existing applications, and also pursue research collaborations to support the population of the database and the tools that it supports. For the barrier data specifically, what we've done is we've put together a team of technicians who do a manual review of all existing barrier data sets and data points. So we've compiled everything that's existing and acquirable, and that includes some data sharing agreements where there's proprietary data where we exclude certain attributes or certain points where we don't have permission to share them. And then our technicians verify the geolocation using aerial and satellite imagery. We remove duplicates between and within data sets, and we map attributes from different data sources. So the dam name, the dam height, and the owner might come from 3 different data sets. And so we want to make sure that we're not only compiling that into a standardized set of attributes, but we're also tracking where each individual attribute came from in terms of data sources. For the hydro data specifically, what we've done is we've continued the development of what are called the chief tools and services. These are open source tools that were originally developed by Natural Resources Canada, but has been put to the side. So we've picked this up and are devoting resources to flow path and catchment tools. And so what these tools allow us to do is take NHN work units, so watershed scale hydro networks, run them through the tools, and it makes sure that everything is clean, everything is connected, the flow directions are properly assigned, the primary and secondary flow paths are properly assigned, and it also populates some additional attributes like stream order and things like that. And in the future, what these tools will actually do is actually support web services that will allow some of this analysis to occur directly through the web interface rather than having to download the data and perform that analysis yourself. So what have we accomplished to date? So we have processed and created a standardized data structure or set of attributes for dams, waterfalls, and fishway data. We have made those updates to the chief processing tools, and we have almost completed CABD population for the entire country. We still have 1 province left, I think, that we're working through in terms of the data processing. So what we have so far is we have over 30,000 dams in the database, over 10,000 waterfalls, and over 400 fishways so far. And we're always looking to add more data sets and sources. So the timing of this webinar is actually very fortuitous because we are planning a sneak peek launch in the next couple of weeks in early November, where we will launch the dam, waterfall, fishway, and hydro network data for 8 pilot regions across the country. This will allow users to explore the tools, the attributes, view the data sources, and actually download the barrier data in CSV format. And between now and March, April 2022, we'll be releasing data for the remainder of the country, province by province, in chunks over the coming months. Okay, so leading up to the public launch, it means that we actually have a working web tool. So I thought I would take some time to provide a little bit of a demo of what we've been able to put together. So this is the Canadian Aquatic Barriers database. You can see here, sorry, you can see here the 8 pilot regions across Canada. So we have 1 in BC, the Berlin Wild Hay system in Alberta, 1 in Ontario, 1 that spans the Ontario-Quebec border, 1 in Quebec proper, New Brunswick, Nova Scotia, and Newfoundland. And so as you can see, we have our dam data classified by passability, waterfall data classified by passability, our fishways, and our hydro networks. So if we zoom into one of our other regions here, this is the Grand Credit River system in Ontario. You'll see we have a bunch of dams, some fishways, and a few waterfalls. So what you can do right now is you can turn different layers on and off, turn dams off, turn waterfalls, fishways, and you can see that dams that are associated with fishways are assigned a partial passability status, and you can also turn the hydro networks on and off, toggle between base map and satellite imagery. And so what you can see is that you can actually see, in some cases, the fishway structures associated with these dams. And what you can do is access the attributes right now by clicking on the barrier point. We have a simple view, which just has some of the key attributes that we've developed, as well as a detailed view with more the full complete attribute set. So you'll notice that there's a lot of unknowns and empty attributes right now. We'll talk about why that is in a little bit, but basically this is phase one where we're compiling what exists. So if attributes aren't populated in existing data sets, we don't have them. And then in phase two, we'll work over time to fill in these data structures. So same thing for fishways. We inherited this data set from Steve Cook's lab at Carleton University. This was the Can Fish Pass data set. And so this is all information that was populated by them, including some important information, fishway type, species known to use, whether or not it's been evaluated through an effectiveness study, things like that. You can also access and view the data sources that we've been able to compile so far. So this is the full list of what's supporting the CBD right now. And currently, what the download feature is any barrier features that are showing in your current map view, you can export them as a CSV, and it will pop up and you'll get a download with the full attribute set for those barriers. And we'll talk about next steps in terms of augmenting those download capabilities in the future. And then this is just a simple contact us email. So over the next few months between now and the spring, we will have complete coverage of dam, waterfall, fishway, and hydro networks across Canada. So that's the demo. So as I mentioned, let's talk about next steps. So really, we want to begin to fill those data gaps as soon as possible. And so part of this public launch is to raise awareness of the tool and start to solicit feedback from people, from groups who might have additional data sets that we haven't captured yet, from individuals who know information about a certain barrier. And so in addition to more formalized mechanisms for filling those data gaps, we do plan on relying on a sort of crowdsourcing type of methodology to do that. We're going to add some more advanced filtering and download functionality this year, so that will be implemented before March 2022. And we're also going to pursue research partnerships to explore remote sensing and modeling tools to help us identify barriers and estimate passability as part of those mechanisms to fill data gaps. And I know that in Alberta and other parts of the country, there's been some great work already on these types of tools. So it's just about seeking out potential partners and coordinating. So just to provide an idea of what's planned, these are just some rough mock-ups that we've done up, but what we'll add is the ability to filter the data by province and territory or by specific watershed, as well as by the feature types, and then you will actually be able to filter based on a small set of attributes. For example, if you wanted to only see all hydro dams in BC, you'd be able to visualize that and download it simply through here or through this more advanced download functionality with multiple download formats. In addition to the CSV, we're going to add the geopackage and shapefile spatial formats, as well as the KML for importing into Google Earth. Additional next steps, and this is one that I think might be of particular interest for folks on this webinar, is we're currently undertaking a review and synthesis of barrier assessment protocols from across North America, including stream crossing protocols, because what we want to try to achieve is we'll explore the feasibility of facilitating data entry for the Canadian Aquatic Barriers database as we add additional barrier types, and trying to standardize a set of protocols across the country. And an example of the modular approach that we want to take is the NAACC protocols, because what we don't want to do is supplant existing protocols where they exist. there's a really great and well-used stream crossing assessment protocol in Alberta. And so we want to try to identify what are the common variables across all protocols. How can we standardize that to work across the country? And are there different modules that we can build to account for some of that geographic or existing protocol differences? For example, I know that there's a lot of focus on sedimentation risk in the assessments in the Alberta protocol, which isn't necessarily a concern in other parts of the country. So maybe one module is the sedimentation that accounts for that difference with the Alberta protocols, so that everyone can keep using their protocols if they would like, but this could help fill some gaps where existing protocols don't exist across the country. And so with the NAACC protocols, you can see that they have non-tidal assessment protocols, tidal, they even have a terrestrial connectivity component, they have a risk of failure or vulnerability component, and these are all different modules that users can choose how much they want to implement. And so to support this, we want to engage with existing protocol developers and users and hold a series of regional workshops in the winter and spring of 2022 to receive input on protocol development and the feasibility of approaching this. We're also going to develop some documentation to support users and applications. So we'll provide a data dictionary, tutorials for how to use the tools, answers for frequently asked questions. All of our data will actually be available for download, but also via an API for more advanced users. So there'll be documentation for the use of that. And in addition to the final hydro networks, the tools that we're developing can actually be downloaded and run by anyone. So if people are interested in running the chief processing tools themselves, we'll have documentation to support that. And then in the longer term, we want to compile and release stream crossing data in 2022 and beyond. We'll take a similar approach where we test this in pilot regions and then expand to the rest of the country. We want to develop analysis and reporting tools, as I mentioned, directly in the interface. So quantifying the amount of habitat or amount of stream kilometers being blocked by a particular barrier, having a connectivity report for a particular watershed, things like that. And we also want to build a connectivity toolbox where we can share resources, best practices, and success stories. And then, as I mentioned, developing or adapting a citizen science mobile app. I know that there's a great app here in Alberta. There's a couple others around the world that have been developed as well. So it's just about evaluating the options and finding opportunities for collaboration and partnership. Yeah, and so that's about it for the CBD. I'm going to take a couple minutes now to shift gears, talk about the watershed connectivity remediation planning framework that we've been developing in BC. So this was developed and piloted in 4 watersheds in BC, and it's what our goal was to establish a collaborative and strategic framework to plan for barrier remediation in a way where we're not allocating scarce remediation resources where they're not needed or where they're providing marginal returns. And so we wanted to develop these watershed scale plans for specific target species that facilitates collaboration, identifies partners and roles they can play. It really focuses the geographic scope to the watershed scale. It allows you to quantify what the current connectivity status of the watershed is, set concrete quantitative goals for improving that connectivity status, prioritize barriers and estimate associated costs that would be required to meet those goals, and then actually develop concrete action plans, including additional conservation actions. So in addition to barrier remediation itself, additional actions like developing supporting the development of Indigenous capacity and education and outreach activities, for example. And so the watershed connectivity remediation plans and the framework, it's adapted from the conservation standards, which is an international planning framework. And so this is a thematic plan that focuses specifically on these physical localized barriers. And because it's this flexible format, it can actually be used as a module, a connectivity module under a broader watershed scale or restoration plan. And it allows us to focus on priority barriers accounting for the watershed context with other threats that might be impacting the freshwater ecosystems in those watersheds, and account for diminishing returns. We can spend as much money as we want on barrier remediation, but there comes a point where the return on investment doesn't necessarily make sense. And these are living documents that are iteratively updated over time. And so really the crux of this planning framework is the engagement and the collaborative planning aspect to it. And so in BC, we're able to bring local partners from all sectors, all levels of government, industry, NGOs, Indigenous groups together as part of a planning team, and through a series of workshops, just develop that local context. We're a national organization, and so we want to avoid that hit and run conservation ethic that sometimes occurs, but also the key part is developing grassroots ownership and buy-in for the plans, making sure that local context and priorities are captured. And so what's great about the framework is that it allows you to build on existing local work or initiatives. In BC, we developed one set of connectivity models and different input data sets. In Alberta, we can build on the great data and modeling work that's currently underway. AEP, ABMI, AWC3, the Foothills Stream Crossing Partnership have all been putting a lot of time and effort into developing these tools. And so we want the goal of this planning framework is to integrate with the other tools, not replace them, while also incorporating Indigenous and local knowledge. So a lot of our data sets in BC were actually augmented by local or Indigenous knowledge, being able to tell us, target species were historically present in this part of the watershed. You have a waterfall in your data set that's impassable. It is actually passable for target species, things like that. And it can be customized. So this framework can be applied for any target species, for any life history, whether that's anadromous fish, resident fluvial populations. It can all be handled. You can use a variety of habitat mapping or modeling methods. You can use any connectivity indicator that you want. And it allows you to actually look at the full suite of barrier types. For example, you can account for dams, rail stream crossings, in addition to road stream crossings, and place those barriers in the context of the watershed and the importance relative to each other. So I'm just going to run through some of the key planning components. So really the basis for everything is connectivity modeling to define the current connectivity status. So that's using data to try to quantify what is currently accessible to target species, what is not currently accessible but would be suitable habitat, where are the barriers. And so you can see in this watershed in BC, because we're dealing with anadromous species, it's all about connectivity to the output of the watershed. Everything in blue is currently accessible. Everything in red is currently being blocked by barriers, and so we can actually see that we can identify some of the key barriers in the watershed as part of this process. And so based on that modeling, we can then say, okay, currently in this example in the Bulkley River watershed in BC, 65% of rearing habitat is currently accessible. So that allows us to set a baseline for the planning work moving forward. Can also look at and run through a planning exercise with the team as a decision support tool to help focus where we implement our planning efforts by looking at the different barrier types and assessing their overall threat within the watershed. So you can see road stream and rail stream crossings came out as high in this watershed. And what that allows you to do is then set goals. So we looked at current connectivity status of being 65% in this watershed. And the project team felt that 80% was where they wanted to get to within 20 years. And so that means that we need to connect 297 kilometers of rearing habitat through barrier remediation and other conservation actions. And so one of the other interesting and useful exercises is what's called a situation analysis. So it actually allows you to look at the impact the different barrier types are having, what contributes to fragmentation for our target species, and it allows us to start to brainstorm what are some of the actions and activities that can be implemented to improve the connectivity status. So obviously the obvious ones, barrier remediation, come into play, but you can see that the project team also identified Working on establishing a First Nations Guardians program to monitor fish passage, making sure that we're engaging with the proper house groups for any work to occur on their territory, requesting regulatory action for non-compliance crossings as a last resort where other methods fail. So it allows us to map out the suite of potential strategies and then actually evaluate them to come up with a final list of what are the actions that we're going to undertake to meet the goals of the plan. And then we can prioritize barriers. So we know that our current status is 65% for rare habitat. We want to get to 80. That means that we need a gain of 296 kilometers. And so there are many different prioritization approaches. One way of looking at it is you can evaluate sets of barriers together instead of just looking at barriers individually. This is what we've applied in BC, and it's flexible enough to be applied in any watershed. But as you can see, barrier 3 in and of itself is maybe not a high value barrier, but when you take it in the context of 3 and 4 as a set of barriers, these two barriers are actually a greater return on investment than barrier 1 and 2 would be as a set of 2. And so we've been able to put all of this into kind of this iterative workflow, starting with the barrier data sets, any kind of connectivity analysis that you want to run, including an initial barrier prioritization, making sure that you have that local partner review. Then you come up with what we call the intermediate list. So the intermediate list allows you to then undertake that field assessment component, which is key. We can't just use a desktop exercise. And so we undertake barrier assessments, undertake habitat confirmations. If they don't pass either of these stages, they get removed from consideration. Eventually, you filter through and get a priority barrier list. You bring that back to the planning team for discussion of additional considerations, barrier type and cost, logistics, cultural value, specific species value, things like that. And then finally, you commission engineering designs before you get to the projects that are actually selected for remediation. And then the final component of this is that it actually allows you to come up with a rough cost estimate of what it would take to reach the goals in the watershed. So this is for the Bulkley, which just has a ton of highway and rail crossings right along the valley bottom that disconnect a ton of habitat for salmon. And so you can see to meet the goals that the group set, $65 million of investment roughly would be needed to meet those goals. And so we are submitting a proposal in partnership with AEP to pilot this framework in Alberta. We're going to apply it in the Berlin Wildhay watershed with a focus on Athabasca rainbow trout and bull trout. And we actually have on our website a guide document for this planning framework that you can check out if you want more information. And that is it for my presentation. So happy to take some questions now.
Thank you so much, Nick. All right, so we will now enter our question and answer period. Just a reminder to attendees, if you would like to ask a question, please use the GoToWebinar panel and type your question through that. Thank you. So it looks like our first few questions are on data quality and data collection. So question 1, is all the data in the Canadian Aquatic Barrier Database voluntarily given?
Yes, yes, we do not take any proprietary data that we don't have permission to share. So it's either open data sources that have an open license associated with them, or data sets that we have established data sharing agreements for.
All right, question 2. What would the quality assurance and quality control on citizen science data look like? Is it possible to separate the data out based on the database it was derived from?
That's a great question, and something that I don't know if we've gone far enough down that road to formalize sort of what those concrete checks would look like. But certainly, one of the options that we've discussed is a data entry portal for trusted or trained users. So one of the things that works well for the North Atlantic Aquatic Connectivity Collaborative, which is an association of I think it's 8 or 10 states in the Northeast US who share a data assessment protocol as a data structure and a crossings database, is that you need to undergo training not only in the assessment protocols but in the data entry, and they have credentials required for login to enter data. So that could be one avenue, or there could be the establishment of QA checks for any data that comes in through an app or a citizen science app or other source. And I think we would talk to, AEP and other groups that have developed their own applications about how they manage some of those data quality issues.
Perfect. Our next question is there a timeline for releasing data for the entire country onto the dashboard? And is there one specifically for Alberta?
Yes. So Alberta is, I believe, our first priority in terms of the next release. So that will likely be in about a month's time, and then sort of maybe not on a pure monthly schedule, but periodically we'll release province by province the barrier data and the hydro network data, with the goal of having 10 provinces and territories released by March 31st, and the remainder by April or May 2022. So the entire country will be covered at the latest in May 2022.
The next question, are you working in concrete with the AEP GIS team? I believe they were working on a similar connectivity model. Has it been outsourced to the CWF?
Yeah, so I've been lucky enough to have worked with Wendy Harrison for a couple of years now. She's part of the working group that I mentioned that provides feedback and input on the CABD. So we're certainly aware of the work that AEP is doing and the dashboard and the tools that they're creating. And so we don't want to necessarily supplant that, but we do want to find ways to help each other out. And so, where we're able to identify and fill data gaps, we can work with AEP to work on that. And when the time comes to add stream crossings, we'll work with them on data sharing relationships. But we have had conversations with their team about making sure that our infrastructures are developed in a way that they can communicate easily and can be updated from each other easily. And so that engagement will continue. In terms of the connectivity indicators and tools, certainly we don't want to reinvent the wheel where some great work has already been done. We're not at the point where we've started development on the analytic tools that we want to implement, so we haven't had those detailed conversations yet. But AEP is one of the core advisory groups that provides feedback for this project.
All right, and the next question is related to the water restoration plans that you were talking about in BC. Who would lead or develop the water restoration plan that you mentioned for BC? Is this the CWF, road owners, provincial government, or other?
Yeah, that's a great question. Because we were piloting the process in BC, CWF led the planning process, because we were still kind of formalizing the planning steps and the framework on the fly as we were going through, and there were a lot of lessons learned. Ideally in the future, though, it would be a clear, with the guidance document and existing plans as an example, CWF could support the implementation, but it would be some kind of local group who would take ownership of the plan and lead that development. So we're actually just submitting a funding proposal for some more watersheds in BC to develop these plans, and we're working with specific First Nations groups who will actually lead the planning process and the implementation of the plan with our support. For the proposed pilot in Alberta, AEP would be leading that in collaboration with other local partners, and we've spoken to some of the key Indigenous groups in the watershed who provided letters of support. So really, it's a watershed to watershed basis who leads the plan, but ideally, moving forward, it is local organizations or local groups or provincial departments.
Perfect. Our next question is on the dashboard again. Where will the dashboard be hosted, and how do we get updates about the status of the Canadian Aquatic Barrier Database?
Yeah, so we do have a dedicated URL that you'll be able to access the dashboard through. We're not ready for the public release quite yet, so I'm not going to provide the link, but basically there's a CABD page on the CWF website that I can include or I can share the link to anyone with that will provide updates and the links for access to the web tool and the data sets. And actually, there was a second part of that question I think I missed.
Yeah, so I believe the second part was how do we get updates on the status of the database, but I believe you said those through the site.
Yes, and we'll also have some social media posts whenever a new province or new set of data is released as well. So there's multiple avenues of communication, but mainly it would be through our website and our social media where that's occurring.
Perfect. It looks like that was the last of our questions for today. So I want to thank you very much, Nick, for that wonderful presentation, and to all of those who have joined today. With continued education and information sharing, we believe we can fix this provincially significant issue. Please join us again Tuesday, October 26th for our next webinar on watercourse crossing regulatory and permitting, presented by Mike Honka from the Alberta Environment and Parks. All right, thank you very much, everyone.